Hello everyone, welcome to Digital Futures event. Welcome to our Saturday meeting. Welcome to Inclusive Futures. أهلا بكم ومرحبا بكم. سعداء بوجودكم معنا. Today we have a very interesting meeting. We have a very interesting presentation regarding our weekly event. Sorry for being late. We have technical issues, but it's fine now. I'll share my screen just a minute. Sorry for this. Okay. Okay. Today, in our meeting, Inclusive Futures exhibition, we'll have a workshop exhibition regarding Africa and Middle East. And today we have a very talented presenters regarding what we have through the festival. We were lucky to have a hybrid workshop and other technical project-based workshops and a tutorial-based workshop. So let's start with this. Regarding the hybrid workshop, we have the AUC Fabrication Lab, the Robotic 3D metal printing WAM for additive manufacturing, Sentinel Lab in the AUC in Cairo here in Egypt. And we have other workshops, project tutorial workshop for space architecture by Professor Samer Sayari, and evolving morphologies by Zaid Motlib and Hiba Ez, and other AI workshop by Mohammed Bijou. And we have a tutorial workshop by me. I'll do a very quick introduction about this tutorial workshop, and then we will start our event. Regarding this tutorial workshop done by me, you can join us on Discord on reparameterized server. I'm offering technical support for everyone just for free and forever. We are here to support you and help you to gain the knowledge needed to build your future and start your career and so on. So I was lucky in my workshop that I have 3,756 total views on Facebook for the workshop, 120 plus workshop applicants in the 4 days tutorial workshop. I am Ahmed Hassab, lecturer at the American University in Cairo and senior architect at Engineering Consultants Group, Digital Futures committee member, and authorized Rhino trainer from McNeil, Barcelona. I'll do other tutorial workshop on Digital Futures live streaming every Saturday. It will be like a 5-hour tutorial at 4th of September 2021. Today, I'm sharing the session with my friend and colleague, Aya. She will introduce herself and then we will start our event.
Thank you so much, Ahmed, for this. Hi, everyone. My name is Aya Riyad. I'm the Middle East Regional Manager at Digital Futures. I would like to welcome you all to the Africa and the Middle East workshops highlights from our Inclusive Futures event 2021. I would like to briefly introduce myself. I'm an Egyptian architect and design researcher based in the United Arab Emirates. I'm currently a doctorate of design candidate at Florida International University with Professor Neil Leach, and I'm a master's graduate from the DRL program at the Architecture Association School of Architecture. This summer with Inclusive Futures, we had plenty of exciting workshops from leading instructors in the Middle East region that covered various engaging topics that were taught in English, Farsi, and Arabic. We are honored to have some of these instructors with us today to present an overview of their workshops, share some of the interesting students' outcomes, and their overall experience with Inclusive Futures this year. I will give you a quick brief about our presenters. We have Professor Zaid Motlib and Hiba Ez that will be presenting their workshop titled Evolving Morphologies, Interacting in Evolutionary Algorithms. And we also have Mohammed Bijou, who is also a fellow team member at Digital Futures, who will be presenting 2 of his workshops, one titled Nature, Computational Design, and Grasshopper, and the other one is the Artificial Intelligence in Architecture. I will now take it back to Ahmed to start with our first presenter. Thank you.
Thanks, Aya. Thanks. As I mentioned, we were lucky to have a hybrid workshop. So we will start with the hybrid workshop from the AUC Fabrication Lab with my colleague Omar Gnedi, who will present and introduce himself firstly. So Omar, floor is yours. Thanks.
Thank you, Ahmed, and thank you, Aya, for this introduction. I will get right into it. So we can just wait a second here. So we are at the AUC, Additive Manufacturing Centennial Lab. We organized this workshop about robotic wire arc additive manufacturing. So basically, it's 3D metal printing using robots. This workshop was organized jointly by the mechanical department and the architecture department at the American University in Cairo. It utilized the facilities we had at the lab, at the Additive Manufacturing Centennial Lab at the university. It aimed to introduce concepts and techniques of robotic 3D metal printing for architects, who was like the focus of fabricating complex architectural geometries and forms, reducing material waste in comparison to other techniques. So our workshop ran for a duration of 2 weeks. It involved 14 hours of teaching and 10 hours of hands-on assignments. It had planned breaks in the middle for participants to work on their projects and their scripts. This was the first of its kind to be organized by our lab at the AUC. So it was a big challenge for us to take. We initially planned to start with a very small group, 8 students, but we received a great number of applications. So we switched our strategy and we tried to maximize the number of applicants that we can receive. And we ended up accepting nearly triple that number. We had applicants from 11 different countries with different backgrounds: architects, mechanical engineers, and artists. We also had different academic levels. So we had students, fresh grad, master students, PhD, professors. So this huge variation was a big challenge for us, of course, especially when we are preparing 15 hours of teaching content for such a diverse group. This required from the whole team, huge effort and dedication and continuous update of the material throughout the workshop to match our group. We're very satisfied with the outcome, and we're very happy with the amazing group that we ended up making this workshop with. We saw a lot of dedication from the participants. We saw people who were attending during weekends or after a hectic day at work, or waking up in the middle of the night due to the time difference to attend. We're very, very happy with what we reached. So I will share now my screen to start the presentation. Okay. So about the workshop, so the workshop instructors were Professor Hamadi Salem, Professor of Materials and Chair of Mechanical Department at the EUC, and Dr. Sharif Murad, Professor of Architecture at the EUC, and myself, Engineer Omar Gnedi. I'm an architect. I graduated from Masters in Robotics and Advanced Construction in IAC in Spain, and I work at the AUC Additive Manufacturing Centennial Lab, and with my colleague Ahmed El-Sukati. So we have a variation of backgrounds. So Dr. Sharif and me, we come from architecture background. Professor Hamadi and Engineer Ahmed come from mechanical engineering background. So the workshop outline, this is how we narrowed down the topics throughout the workshop. So we started first with introduction to what is WAM, and what is robotics in architecture, and then we start narrowing down and talking about the design considerations for WAM, and then introducing the workshop main topic, which is non-planar printing for 3D metal printing. And then we started digging into the tutorials, so design tutorials, robotic programming tutorials, robotic simulation tutorials, operating WAM, and then showcasing or lecture about the actual part that we fabricated at the lab. This was the schedule. It involved these 2 planned breaks for sharing for the participants to work on their projects. This was a hybrid workshop, so it was done both online and at the lab. It was done at the additive manufacturing scenario, as we mentioned, which is the first robotic metal wire-based additive manufacturing system in Egypt and the region. And we're very proud of that. So in this video here, it shows like the basic structure and the facilities we have at the lab. So this is our lab. We have these two robots here. One that does in the wire arc additive manufacturing WAM. So this is and we have the positioner here, which is considered the third robot. So this is the first one with the tool head for the wire for the WAM. And this is like the power source we use for this with this robot, and this is the positioner we use, which adds 2 extra axes for our integrated system. So we end up having 6 axes from each robot and 2 axes from this positioner, which adds to our degree of freedom. We have also this another robot which works as a subtractive robot. So it does milling and surface finish for the parts that we print using the other robot. Okay, I will continue. So the workshop topic, the main topic about the workshop was about non-planar 3D printing. To understand this, if you have a shape like this, you have different ways in which you can do the slicing. The first one is planar slicing, which is the normal that you would use in any other, using like Cura or any other software, or like when you're doing normal 3D printing. But the problem with that, you will see that there are layers that starts and ends at like in the way you can see here. So you end up having more layers here than the number of layers here. This makes some problem, especially when working with BAM, the start and end of each print. So we try to introduce this idea of non-planar 3D printing by having a variation of the height of each layer that we print, so that we end up having variation in each layer, and we have for the same geometry, which is like non-uniform geometry, we can have this variation in heights without having to change the total number of layers inside it. Of course, this is not a new idea, but it's there in concrete, it's there in clay, it's there in plastic. But when you're trying to do this with metal, it's very, very, very complicated due to the parameters and all of the stuff involved. So this was the idea that we were trying to dig deep into during this workshop. It has a lot of benefits. So it has like need, start, and end. It has improved control over the deposition parameters that we're using. It expands the geometrical possibilities, and it can also add an ornamental effect. Still, mechanical properties are to be verified as part of our research in the lab. So just like a very quick overview of the geometrical possibilities. So if you have like a shape like this, a tube, if you're doing a planar slicing, this is how you will end up slicing it, all of the layers parallel to each other. This, you will face problems at this part here, because you will need supports to do that. You can instead do it this way, so you have the layers sliced in this manner, and you will be able to print this kind of shape. You can also do like some branching effects, and it could be also mixed with planar slicing. I'm not gonna dig deep into this because this was like a whole session about this. As I mentioned earlier, there's a difference between clay and metal, and why metal is far more difficult to achieve this with metal than clay. Just a quick overview. In clay, you can slow down the robot, or you can elevate the tool head a little bit, and you can deposit more material, and it will fill the gap between the tool head or the nozzle and the print surface or the layer beneath. With metal printing, the arc starts at the bottom of the layer. So you have to have the parameters or the data that generates the layer height that you wish to achieve. So it has nothing to do with the height of the nozzle. It's all about the electricity that you're using, like the current that you're using, and the feed rate, and these equations that happen together, and the material that you're using. So this was why it was tricky. At first, we did some initial proof of concept. So we tried testing different parameters and how we can switch from one parameter to another. And then we ended up making this first proof of concept, which is like a small cup, but it's just like printed non-planar in a non-planar way. So you have this, like with using the same number of layers, you have parts that are higher than the other part. So during the workshop session, we started with Dr. Professor Hanadi started up talking about WAM, what is WAM, and talking first about additive manufacturing, and then WAM and why WAM, and all of the things related to that. And then in the next day, Dr. Sharif started introducing robotics in architecture, and at the end, showing the potentials of using 3D metal printing in architecture. We then started having grasshopper sessions on the design, how we can design non-planar parts, and we did a quick revision on data tree structures, and then started working on the robotic programming inside Grasshopper, couple or like 3 sessions on that, and how we can optimize the robotic movement. So we're using this positioner, and this positioner rotates in 2 axes. So how we can use this to complement our fabrication process and making it much easier and optimizing our movement. Also, Engineer Ahmed gave a lecture about welding parameters and the power source we're using, and how to select these welding parameters, and also some instructions about how the robot moves in one line of code from one point to another. And then in our live sessions from the lab, we were explaining all of this live at the lab while running the robots, and then explaining also using parts that we printed previously and the tools that we used, and then talking about the process that we started making during the workshop. We also received a lot of participation from a lot of contribution from our participants. So we had Dr. Ines from ETH, Damazi Koller, who's doing her PhD in WAM. She started giving us lectures or insights on her research. We also had another contribution from Dr. Vittoria, who's also did her PhD in WAM, and started sharing with us all of the work that she did. And then many discussions with the participants and sharing of insights. And so it was really nice contribution from their side. So the workshop output, we started printing this, depositing this part here. So you can see here the robot running and depositing metal, and you can see here the positioner working in 2 axes to optimize the movement of the robot. So you have the robot always, the tool head always pointed perpendicular to the layer that is being printed, and it doesn't move much because of the second axis here, which is rotating the robot and rotating every target to the robot, so that the robot is optimized as much as possible, which makes the process faster. This is just like a preview of the printing process that we did during the workshop from different views. And you can see the layers starting to build up, and the non-planar effect starting to accumulate at the end and show. We will be sharing more details regarding that in the following weeks. We had every participant working on his own project, so they all designed a piece and then generated the robotic fabrication code for this piece. So we had a number of really interesting videos and projects that we will be also sharing later on. Our next stages, we will have like a summary video for the workshop, which will be shared on our website, amcl-auc.com. We are thinking of like having a possible publication about the idea of non-planar 3D printing and including the workshop output as part of this research. We have another workshop planned coming up here in Egypt, like actual physical workshop, and we will be publishing parts of this workshop as a robotic programming crash course that will be available for anyone to see. Thank you very much. If you have any questions.
Thanks, Omar, for this amazing presentation. I believe we have a lot of questions, but we will have the questions by the end. So if you have any questions, you can write down your questions on YouTube or Pili or on Discord, and we will pass it to the presenters. Now we will move to the second presenter, Professor Samer Sayari. So please join us. He is award-winning architect, joined a lot of research with a lot of institutions around the world, and he is NASA ambassador. Professor Samer, would you please introduce yourself and start your presentation? Thanks.
Hello, everyone. It really brings me pleasure today to be among you. Please let me introduce myself through the presentation. My presentation today will be divided into three main parts. First of all, who am I? What is my design methodology or education methodology, and the output, what we have done through this workshop. So first of all, I do define myself as a science tech. Science tech is the one who is using science to produce architecture and then turning this architecture into science by turning it into scientific papers. So actually, it's so rarely and scarcely to have a client, a real life scenario client. So I do work for governments, I do work for institutions, and it's a closed cycle, taking science into architecture and then turning architecture into science back again. So I do believe that the space architecture all will serve mankind on Earth before it does in space. And this is the purpose of the whole streamline that I'm working on, designing for space, and is not like education and learning for space. If we are learning for space, so that means that we will be using this knowledge and this kind of science both in space and back on Earth. First, let me introduce myself briefly. I'm an award-winning architect. So far till June 2021, I've gained 39 awards all over the world in 4 different continents. My space architecture is from United States to Europe to Asia, Far Asia. So this is the timeline and the history line of awarded projects just in space architecture. For the exhibition map, these are the set of countries that I've exhibited my work, including space architecture and non-space architecture, Earth architecture. One of the key exhibitions was NASA Johnson Space in Houston, 2019, MedCop 21 in France, 2015, and Paris again in 2016, Greece 2015, Tunisia, Egypt, Malaysia, among many other several countries as shown on the map. For the workshops, of course, it's also part of my, I might say, manifesto, is to deliver this kind of knowledge to the future generation. So it's not only a closed cycle of turning science into architecture and architecture to science, but delivering the whole process to the others. So the others can just pass this science to other generations. And this is the core concept of sustainability in science. This is what I do believe in. I had the honor to be interviewed or to be featured or to be televised in this set of brand names, Discovery, UK, Forbes Middle East, that was last month ago, our L'Architecture d'aujourd'hui in France, NASA, as I mentioned earlier, among many others. Also, part of my message is to deliver this design manifesto to other countries, other cultures, and trying to deliver this message, which was started 20 years ago, and still I'm working on it. That was during NASA Johnson Space Center. And of course, science couldn't be really done without learning from experts. So also I had the privilege to visit SpaceX, Virgin Galactic, with, of course, learning from NASA senior engineers, and trying to build my first prototype in 2017 in Mojave Desert. That was during my ambassadorship with a Mars City design. So turning now to the second part of my presentation today, what we have been learning, what we are doing. So the first motto: if we possess the technology to terraform Mars, then we can eliminate climate change. And let me just speak a little bit extensively about this point. We have 16 different existential risks that are threatening the future of our human race. Space technology guarantees eliminating like 15 of these existential risks: non-political, non-socioeconomical part, anything that is regarding technology. We can really reverse the action of these existential risks using the education and the knowledge gained from space technology. So let me also dig a little bit deeper in the design manifesto. I have taught during this workshop 3 steps, which I can define by the community-centered design. So first of all, also, we are inspired by nature. As Le Corbusier once said, you know, always nature that is right and the architect who is wrong. So it's all about emulating the models, systems, or elements inspired by nature. Nature is the mentor. Nature is the inspiring model. So it gives us solutions to merely any kind of engineering problems. Nature is so much older than our human existence on Earth, and it managed to survive. We are, according to anthropologists, 3.5 million years old, our human race, but nature is billions. Earth had born through billions of years ago, and it's still surviving. Before our precedents were maybe the dinosaurs and the primitive life forms, but nature and trees exactly has survived through millions and billions of years. So we have to turn our face toward these solutions and try to get inspired and analyze and study this kind of solutions and turn it into physical forms that we can make use out of it. So now this is the second part: experimenting and developing. We have today merely high value cutting edge technologies. I once heard Bill Gates in 2003 with a very interesting quote. This guy said that the technology that occurred in the last year is equal to the technology that occurred in the last 10 years. And what happened in the last 10 years are equal to what happened in the last 100 years. And all of the set of technologies that we have invented during our last 100 years are equal to the whole human race technology and our whole humanity. So that means that we are in a very accelerating pace. We have to make use of it. We will reach a point maybe in the post-singular future, post-singularity, or the post-scarcity, according to futurists, that the technology that will exist in the morning will be different from the noon, and the technology that will occur in the evening will be different from the noon. So on the on the span of one day, you might have a technology that might occur in maybe ages in the past. So the core concept here is we have to make use out of this technology. We have to redefine and rethink what our ancestors had left to us and start delivering that to our future generations, that we will be taking our legacy that we have left and start again and again developing, and all for the prosperity of our human race. The third part is experimenting and publishing these experiments through projects, through papers, and through workshops. That the one I'll be presenting the output out of it today. So this is the third part. I do believe that we are in the middle link between what our ancestors had left us and the legacy that we will be delivering to the future generation that will occur after 500 years and maybe thousands of years from now. The topic of the workshop was the orbital elevators or the space elevators. The space elevator or the orbital elevator is not science fiction anymore. It is a project that could be designed and implemented by today's technology. Our space elevator or orbital elevator was a lunar space elevator. We do have possess all the technology that is necessary to build such an elevator. So why did we choose that specific item or that specific topic? Because we do believe that the space elevators, it will be the heavy railroad and the catalyst for the sixth industrial revolution. If we have defined the fourth industrial revolution, the revolution of the AI and the artificial intelligence, and reaching to the point of the post-singularity, which is sharing our human intelligence with the artificial intelligence. So we do believe that the fifth technology of the fifth industrial revolution will be the post-AI technology, and definitely it will witness the start of the space economy. And for sure, the sixth industrial revolution will all about the space economy and the emergence of new concepts and new notions as the space trillionaires and the space communities and the space and we do believe that our human race will be an interplanetary with, of course, mixing this concept of the post-singularity, which is sharing our human intelligence with the AI or the artificial intelligence. So that might result in new kind of human race that is hybrid kind of race between machines and humans. And this is where it comes. And this kind of a new world, we will be in a very deep need of a heavy railroad that will be transferring our goods and our resources and sharing our resources between these interplanetary communities. And here is the need for the space elevators. The space elevator, this is a project that is awarded in 2020. Sorry, that was just like 7 months ago. And it is inspired from the biomimicry. This project was developed and designed by a mix of digital technologies, the biomimicry, the biomorphism, and the biophilic. So the mechanism of opening and closing of the lens, of course, by the way, this is not only an orbital elevator, it is also as telescopic installation or facility that will be serving science, that will be serving industry at the same time. So the mechanism of closing and opening is inspired and developed with the muscles of the iris. And the iris, by the way, the really fun part here is that one of the definitions of iris was the messenger of gods in ancient Greeks. So the space elevator will be also the messenger that will be connecting different communities, the space communities, and different human races in different planets and interstellar celestial bodies. Here comes the second part with the biophilic, creating part of Mother Earth, which will be our ultimate legacy, something that is connected and hardwired inside our brains that we cannot really leave behind. So the underground part of the same project, which was the subterranean on the lunar surface, is designed by importing part of the moon, of the Mother Earth, with its terraced landscape, and trying to make a micro ecological environment in the subterranean part of the moon by creating this kind of a natural life support system to not only support the physical needs of the residents and the new community, but also the psychological needs, including many topics at the circadian cycle, which is important for our mental health well-being. And having this kind of delicate balance is just only the small seed for a higher purpose, which is the terraforming of these kind of celestial bodies. If it is not on the surface, it might be under the surface in the lunar caves. And all of these concepts and knowledge and science were delivered to our students in the workshop. And of course, with a little bit of research that was asked out of our participants, they started understanding the implications of having this kind of approach. The cost effectiveness of the construction was also introduced to the students, and the set of technologies that are available for today and will be available in the next decade were also explained thoroughly to our students, including the nanotechnologies that will be needed to make the tether of this elevator, the necessary calculations, and having a full self-sufficient in terms of energy and the water production and the food production of the closed community to support and thrive and to survive through the harsh environment of moon. This will be the shape that we think that will be available as a permanent industrial base and scientific base, and it will be merely the fourth kind of settlement. We have 4 phases of human settlements, as anthropologists has told us before. So this is a mature kind of community. This is a permanent base. Just before declaring an independence community, this is the community that will be connected to our motherland and having shared resources between Earth and Moon, exporting helium-3 and getting all kind of life forms, plants, cattle, maybe kettles, water, which will be the most scarce resource in the whole of the solar system. And lastly, the biomorphism, which is very important for our psychological well-being. Also, part of the geological survey were explained to our students to understand the implications and the thriving that could be achieved using the lunar lava caves, and the possible dimensions that were conducted by many studies by Purdue University and NASA, of course, published papers. It will be an internal and external transportation system, internal on the surface of the moon, connecting various parts of the planet or the moon, and also an external transportation system linking the moon with Earth and Mars and maybe beyond. The powering engineering systems, and it was the really fun part here and the exciting part here, that this workshop has only had a duration of 4 days, and during those 4 days, this distinguished group had succeeded and managed to produce the following projects. That is project by Suhaib. Suhaib Rahmani is from Iran, and he has fused time and space. He had this very interesting quantum approach of using the time and space by having a rotating kind of habitats, producing artificial gravity and stabilizing the human presence on the floating part, on the orbital part of the space elevator. And moving on to Walter. Walter is an experienced architect from Puerto Rico. He used the dandelion as a biomimicry approach for creating his space elevator. And of course, I would like to mention that this is a very, very brief slides of the results of the workshop. Each one of them had really dug inside into a very high level of research before going through the generation of the solution. And we have discussed the solution, and it was very interesting to have the power of all of the minds and unlocking synergies between the group to have the end result of this workshop. Also, Yasmin is a graduate from the American University in Cairo. She had clustered her habitats in a modular design and composable design after understanding the differences between the modular design principles in engineering and the composability and the synergies that could be done. And she had went so far to the design of the single unit and its air locking system and its window and the external structure that will be the carrier and the protector of the internal unit. And also from the United Arab Emirates also had interestedly designed the Mobius curve, the infinite Mobius curve. It is an inside space that while wandering and walking from its first beginning to its end, it's an infinite kind of cycle. You don't have a beginning or an end inside this kind of architecture. And Valentina Pruselli also had produced us something very interesting, linking the craters. She had went a little bit out of our approach of using the lunar lava caves, and she was interested more in exploring the craters on the lunar surface. And we have left her the freedom to design her space, but of course, accordingly, she had also to dig a little bit deeper in the research to convince the whole group with the cost effectiveness and the scientific and implementation effectiveness of her design solution. And she had thought about the movement mechanism, linking the orbital station with the Terran station. Also, Aline had interestingly made a set of orbital elevators, resulting in a parallel community that is linked together in parallel to the lunar surface. So she had like and subterranean communities and an orbital kind of communities with expansion possibilities done using the modular design of each space elevator and having like a cloud cover covering the lunar surface of this modular units. And now turning to Ethni Zhu. Ethni Zhu is a graduate also from Yale University, and she interestingly had started about thinking about the inner solution of the vehicular, or the vehicle that will be linking the subterranean or the terrain with the orbital stations, and how it could be hosting safely the crew that will be moving at very high speed in a very low gravity environment between both stations, the orbital and the terrain one. And Joel from India also had thought about the movement and the dynamic units and how it might link our community on Moon and on Earth by importing many of the life principles on Earth and importing it into the new environment. And lastly, we have our friend here from Sudan, and I was really impressed by his work regarding that he was working under a very harsh environment. He had only 10 hours per day of electricity. The place that he is living in, there's a severe scarcity in resources, but he managed to do a good solution in a very limited resources. Last thing that I would like to end my presentation is, I do believe, as the three quotes that I'm presenting now, the future belongs to those who dare to dream. And Eleanor Roosevelt added, the future belongs to those who believe in the beauty of their dreams. And lastly, Malcolm X had added that the future belongs to those who prepare for it today. So wrapping things up, we have to dare, we have to believe, and we have to work. And I think that is one of the core understanding and principles of digital futures, and upon I have agreed to deliver this workshop. Thank you all for this presentation. Sorry if it was a little bit longer than it was expected. I have enjoyed being here with you today and sharing some of our output with you all guys. Thank you so much.
Wow, that's amazing. It looks we are ready to start building the habitats needing to start the space exploration. Thanks, Professor Samer. That's so promising and so innovative. I'm happy to see the results, and thanks for your effort. If there is any questions from the audience, you can write down your questions on YouTube or Discord, as we mentioned before, on Pili. So Professor Samer can answer your questions. Now we are moving to the next presenter, Aya. Please join me and invite the next presenter.
Thank you. Thank you so much, Ahmed, and thank you to all of our instructors. These were truly interesting presentations. I would like now to take the opportunity to introduce our next workshop taught by Zayad Mutlab and Hebaz. Zayad is an associate professor at XJTLU in China. He's an interdisciplinary architect, designer, and a researcher on human algorithm interaction in information-based design processes. In 2014, he founded Amorpho Studio, an award-winning visionary architecture and design studio based in Dubai and Sydney, and UNAT, United Network of Art, Architecture, and Technology, a research-based collaborative network exploring design possibilities at the intersection of nature, design, and technology. He taught the workshop alongside Hebaz, who is currently pursuing her master's degree in architectural computation at the Bartlett School of Architecture in University College London, where she is also working as a postgraduate teaching assistant. Together, they taught the workshop titled Evolving Morphologies, Interacting in Evolutionary Algorithms. The workshop explored interactivity in genetic algorithms as an exploratory and an optimization process to design high-rise morphologies in selected urban contexts. Welcome, Ziad and Heba. The floor is yours now.
Thank you, Aya, for the introduction. Well, you said it all, so I'll go straight and share my screen. This is not working. Oh, okay, is my screen there? Am I sure?
Yeah, it's perfect.
Okay. Okay. Yeah. Again, thank you, Aya, for the introduction. The workshop that we run, Evolving Morphology Interaction in Evolutionary Algorithm. Sorry. Yeah, okay, now it's working. Where we had 14 or 15 participants, exploring that subject. Interacting in evolutionary algorithm is a current research that I'm working on along with Hibais, who is creating a custom-made tool or plugin that allows certain level of interactivity in genetic algorithms. So as we propose that as a new design method to explore high-rise morphologies in urban context, applying that method into real projects outside of that of the selection of the participants themselves. So the
Zayed,
process.
I'm really sorry to interrupt you. Can you make sure your screen is full screen?
Okay. Sorry. Yeah. Okay. Now I think
Thank you.
there is a time lag. Yeah. Thank you. So the workshop structure, first, we wanted to introduce the concept of genetic algorithm because it is something new for architectural students, and how the current genetic algorithm works to be able to introduce the concept of interactivity with it. So current genetic algorithms, they work very much like a black box where they don't allow, where they basically require the architect to define the objectives and the aims in the beginning, and then they take their own course processing and delivering certain outcomes based on that. So the architect role in this workflow became more of designing the problem itself rather than designing solutions. So, and as well as one of their aspects that they don't allow the architect to intervene in the process to introduce certain selection or subjectivity, so to speak, into the process of the algorithms themselves. So the research that I'm working on is to literally try to unpack that black box and to allow for certain level of interactivity with it, so as to bring in architect subjectivity and personal preference into the population that the algorithm is generating throughout the different generations of the process. So that kind of required certain learning curve because we had to go and explain these vocabularies of a new design method, to the participants themselves, familiarize them with that. So we went into trying to make them understand what really how genetic algorithm work. Genetic algorithm work very much in an analog way to natural evolution. They are one strand of the evolutionary algorithms. So we want them to understand how that process works of the algorithm itself of 4 or 5 or 6 stages from initialization, evaluating, mating pool, and then creating parents, children, and mutating children, and so on. And how that process, which is very much analog to the process of evolution in nature, help producing different variety of species, and optimize, I would say, varieties of species. So in the beginning, it took us the first 2 days, we went on exploring or explaining these theoretical concepts behind the algorithm itself. The idea is that we wanted everyone to understand really what's happening inside the algorithm, because current tools that architect became familiar with genetic algorithm approximately from 2014, when Galapagos became a plugin for Grasshopper, and everyone realized there's something called optimization, even though it's a single optimizing algorithm that, Galapagos. Later on, Octopus came as multi-objective optimization algorithm, which takes on certain conflicting objectives and try to negotiate between them to produce particular solutions. However, both of them, they are not really interactive. So all what the architects do is to go in the beginning and to specify the genes, the objectives, the number of generations, population of the algorithm, run its course, and produce whatever outcome. And that's why it's mostly being used for engineering purposes, because they purely objective optimizing processes, while architects, the nature of our work require more explorative nature. So to allow that explorative nature and to allow the architect may introduce preference that not really necessarily based on performance, it's based on, could be visual, could be proportion, could be other aspects that architect like to have their say in it, so to speak, so that to be able to direct or guide the evolution towards a certain outcome. So the research is actually is a part of a bigger picture, which is to do with the interaction between human and computers. Because when we talk about that, human, the way we design is more based on intuition, perception, creativity, while computers are known for being algorithmic, logical, and precise. So the idea is, if we are to create a collaborative system using the strength of both of these media, the human and the computer, as a design process. So in a way, we are taking the qualitative objective, what we call that's bringing architects' experience and knowledge into the process, while the computer that is more the objective, using the quantitative objective thing. So the idea is that how do I really introduce the human back into the process, trying to create a more collaborative system using the strength of both. And then the design will be exploring opportunities at the intersection of this collaboration. What we did is we have, I think, 14 participants. We divided them into 4 groups, and each group we specified a problem, a design problem, and let them explore it using this method. So instead of thinking of outcomes as naturally happens, they start to thinking of how do I design the problem itself, and let the designing of the problem suggest or produce a particular outcome, or what we call a space of possible solutions. So we're not really looking at one particular outcome, we're looking at that space of possible solution that would allow for architect interactivity. Now, that was the ambition, of course, of the workshop, to use that custom-made plugin that Hiba developed. However, we realized actually creating this shift in the method of thinking of the participant required more time than what we anticipated in the beginning, because participants here, they need to think of their design as genes, as objectives, as how do they relate the genes to the objectives. And then designing the problem became very crucial to the outcome itself, which they took longer doing it in the non-interactive. So we basically gave them an octopus definition that kind of work in a non-interactive way, and let each one first design their problem based on that, because we wanted them to understand really the non-interactive mode first before they can jump in and do with the interactive. And then we ran out of time in the workshop, unfortunately. So that interactive mode, we kind of gonna make it in another workshop later on. But the work I'm gonna show you now is diverse work, because it's 4 different projects that they use is a more of non-interactive, but they managed to think of the design as more of genes and objectives, and what space of possible solutions that you get out of it, which is very different to the normal analog or even parametric way when you think about design. So each one has one particular problem that they explored. So the design, the kind of exercise was very simple, like we gave them the problem and we let them explore it their way. So the first project is that dealing with an existing, for example, buildings that was in Singapore. Construct a problem. We thought we unskin it first, leaving only the structure, which is floor plates and columns, and then design a new skin for it based on particular performance objectives. In this case, they wanted to reduce the radiation because they thought the facade that facing the park, the main important one, is the one that has highest radiation. And then the algorithmic exercise became, if we are to propose 50% of balconies on that elevation, each balcony varies in depth between 1 meter to 3 meters, I think, then the algorithm will figure out positions of these balconies with varying depth to give us minimum radiation. So these are, they learned how to get, what are my genes here, what are my objectives here, how the algorithm will go to create different generation, each generation propose different balconies and project positions and projections into the elevation. So it became what looks like random pixelized, but actually it is informed by certain performance criteria that will drive the aesthetic or the arrangement behind it. So that's generation 1, generation 2. So that the project to take it forward when the subjectivity of the architect come and say, well, I really like that, or I want to understand how the algorithm is actually proposing the balconies there and be able to interact and influence that project towards something that is aesthetically appealing to the architect. So that I would say just phase 1, of the process that we are working on. And the other project is a photovoltaic tower, taking a different context, and it is Dubai in this case, and what the participant found in his existing site among certain towers in Dubai, and they wanted to propose a photovoltaic tower that the tower need to negotiate between viewing objectives, so to have the best views, as well as have the minimum glare inside, but to maximize solar harvesting on the skin. So there are like 3 conflicting objectives between maximize solar harvesting, which means more radiation, meanwhile reducing the glare on the floor and maximizing the views. And then the algorithm generate what, like they looked at the Pareto front and they make their own selection. And they found out the different generations that you can actually meet this objective. And now the architect can come and select which one that subjectively have different preference and feed it into the loop and see how would that really evolve into their aim at the end. The other project, moving from a single tower to a group of tower, and this time the participants selected a site in London, and they want to propose 3 high-rise buildings there. So they started with generic shape, which is a cylinder high-rise. And the first thing they want to propose is that they want the algorithm to figure out a combination or a way of organizing these towers to minimize overshadowing of each other. So algorithm will go and have different placement and height to figure out which iteration that gives them minimum overshadowing. With the minimum overshadowing, they introduce another objective, which is they want to have best views to a certain London, for example, points or focal points. So they studied now between the conflicting between the overshadowing between the views, and then how is that really going to impact the placement of these things, which is very much the first step. You take it when you have a project like that. The architect, when they do it manually, they kind of position them in a way that they think this is the best. Here, the algorithm can give you many options to really position them. The architect can select the one that they feel they have more preference. And from here, they take it to the next step, which is they go into the morphology of the tower itself. And then they're trying to introduce rotation, give it a character based on architect things, knowing that this is the best positions. Now, what is the best morphology that can reinforce their selection? So from a multi-story urban kind of application for this process, we went on to a completely contrasting one for the daylight pavilion, taking like a small site that 20 by 20 meters somewhere in a park in Iran, because the participants were Iranian here. And what they want to do is to figure out shape or a geometry for the roof that will basically, this is going to be a study hall. They want to figure out a shape for the roof with the roof overhang to give them zero glare inside, so that the roof can take different shapes, different geometries, different overhang. What is the one that's going to give you zero glare, so that the geometry of the roof, although it looks organic, curvilinear, but it's actually informed by a certain performative criteria. So algorithm will go and try to optimize this, so they defining the genes in case this, like the cantilever, the height of the roof, the overall geometry, into optimizing it towards producing zero glare inside. So the subject is really big, so to speak. And this is only like, we took like one slice at it. We weren't able to push it further because we realized for architect to think of design in a different way, to think of design in a more of evolving method rather than generating design solutions immediately, took adjustment to way of thinking of the participant, which kind of hinder the taking them to the next stage when they subjectively try to influence the direction of the evolution of the algorithm, and test that really method, whether architect can really influence and how much can they influence and where is that influence going to take them. So the idea is that we take something that is very objective, which is the genetic algorithm, and we introducing our subjectivity or preference, which is the dominant mode, so to speak, when we design in the generative, in the generating mode, and see how these intersection of two methods were they driving the solution towards. So as I mentioned, it's ongoing, and it's a part of research that I'm currently doing with Hiba, and that was the first step, testing this method on 4 different kind of contexts. And we look forward to the next version, of this workshop when we introduce that interactivity. So I think that's it. Thank you.
Thank you so much, Professor Zayed and Hiba, for sharing your workshop with us. That was really, really interesting to hear. And it's also great to see the workshop's successful outcomes. So I congratulate you for that. I would like to just give our audience a quick reminder to post their questions on our YouTube and Bilibili or to our Discord channels. Okay, moving on to our next presenter, who has recently become a part of our team at Digital Futures, and we are really lucky to have him on board with us, Mohammed Beju. He holds a master's degree from the University of Tehran in Iran, and he is interested in computer science, specifically AI, deep learning, architectural philosophy, and digital interactive design. He has worked on projects that solves issues for deaf people and also on creating virtual environments using motion sensors. Mohammed taught 2 workshops with us at Inclusive Futures this year. They both were in Farsi. The first one was titled Nature, Computational Design and Grasshopper in 7 days, which explored the laws of nature as a driver and inspiration for design and structure. His second workshop, titled Artificial Intelligence in Architecture, Exploring GANs, which looked into the fundamentals of deep learning, neural networks, and cycle GANs. Welcome, Mohammed.
Thank you, Aya, for the introduction. Hello, everyone. My name is Beju. I'm a member of the Computational team. I mentioned this meeting.
Mohammed, if you could please speak a bit closer to your mic.
Yeah, I will do.
All right,
Can you hear me?
I'm sorry, could you repeat again?
Can you hear me?
Yeah, now it's a bit better.
Okay. Let's go on. I have 2 workshops in Inclusive Futures this year. One of them was Nature Computational Design and Grasshopper. It was an intermediate workshop, and both of them were tutorial-based workshops. The other one was about artificial intelligence in architecture, exploring GANs. That was a very advanced, cutting-edge workshop in the field of artificial intelligence, of course. Excuse me. And it was it was a crash course. It was a very quick course on artificial intelligence, from fundamental topics like the differences between machine learning and its subfields like deep learning to more advanced topics like generative adversarial networks, specifically cycle GANs. And okay, let me continue. Let me go to the point. The first workshop was about computational design in Grasshopper. It was taught in 7 days, and the topics that I have taught my students in this workshop was loops, recursions, minimal surfaces, kinetic structures, fractal forms, mathematical sequences, contiguity, and membrane structures, and of course how to implement them into our design with Grasshopper. Our first session was about recursion and how vital and important recursion is in computer science field and computational design. Of course, and we explore it with our students. The procedure of the workshop was that we talked about a specific topic. Each day we go through the fundamentals of the topic, like the origins and the relationship between that field of science. For example, maybe it was a mathematical solution or physical or other fields of science, and the relationship between that field and architectural design. And the second topic was minimal surfaces and their properties. Of course, we can focus on gyroid surfaces, and we have some examples of minimal surfaces that include some catenoids that it is consisted of a rotating catenary form or helicoid surface that is swapped out by a line rotating with a uniform structure, and some other kind of minimal surfaces. I'm not because I'm short in time. I have around 10 minutes, and I should present my both workshops. I skip these parts and I go to this part that it is a very short video. Okay, thank you. It's a very short video of a gyroid surface that is implemented with voxel cubes, and what we discussed about minimal surfaces. The students suggest that we can use voxels to make it a little more unique geometry. And our other topic was mechanisms and kinetic structures. And we know moving or kinetic structures consisted of some mechanisms, and in engineering, mechanism is a device that transforms input force into an output force. Please excuse me. Okay. We know that mechanism is a device that transforms input forces and movement into a desired set of forces and movement. And kinetic structure is consisted of so many of these mechanisms, so many kinds of these mechanisms, and we know some person that who is named Theo Janssen, who made some interesting kinetic structures that actually they can move, and it's a very interesting opportunity to implement this. Implement his designs, his structures that we call them standards in architecture. And we discussed some of the advantages and disadvantages of his design in the architectural realm with our students. And it was a very interesting discussion. Those standards that I call them is some moving structures or moving pieces of art that we call them strands. As he said, the bonds between art and engineering only exist in our minds. And he strives to equip his creations with their own artificial intelligence. So we know that we know that artificial intelligence is not just machine learning or deep learning. It's a subfield of artificial intelligence, and that is mostly famous nowadays. We have lots of forms of artificial intelligence. For example, in his designs of Theo Janssen, he wants to equip his creations with their own artificial intelligence so they can avoid obstacles and they can sense and respond to environmental stimulus. One of our students has implemented this in Grasshopper. So it's a piece of a strand that we saw. It is implemented in 2D. Of course, and we explore some fractal forms, and this video is I remember it. I think some researchers from Princeton University have published some papers that if we do some stimulation to ball bearings with some voltages, they are forming some fractals. And of course, fractals is a type of mathematical shape that are infinitely complex. In a sense, a fractal is a pattern that repeats forever, but their shapes does not have to be exactly identical to be classified as a fractal. Instead, shapes that display inherent and repeating similarities are the main requirement for being classified as a fractal. We discussed what are fractals and we saw some examples of them. And there is an interesting mathematical question, mathematical problem that is called coastline paradox. The coastline paradox is a counterintuitive observation that the coastline of a landmass does not have a well-defined length because of the metric we have. This results from the fractal curve law of the coastlines. So I guess Mandelbrot, Benoit Mandelbrot has expanded this problem and has some definitions for this. Mandelbrot is the person who has the Mandelbrot set of fractals. After that, we went through some topics like game of life, 3D cellular automata, L system, dragon curve, and mathematics of chaos. It was a really funny and interesting session. One of the students have implemented this fractal tree using Robotic component, implementing L system principles in Grasshopper. So after that, our fifth session was about this question: what is a sequence, and what are the examples in nature? And the definitions of the sequences, like being infinite or finite. When the sequence goes over or goes on forever, it is an infinite sequence. Otherwise, it is a finite sequence, or some definitions like sequences does not have just one rule; they have so many rules that define a sequence. Excuse me. We talked about Fibonacci numbers, Lucas numbers, golden ratio, and its roots in ancient Greek and Roman architecture, and arts and types of sequences as arithmetic sequences, geometric sequences, triangular numbers. And after that, our discussion goes toward more geometry talks, like what hyperbolic spirals, Fermat spirals, parabolic spirals, and other kinds of these spirals are, and what are the differences between them. This is a grasshopper script that one of our students have written. That we can have a large variety of sequences and spirals with just a very short script in Grasshopper. I think most of you know where this location is. It is Black Rock Desert. They have an annual festival that is called Burning Man. This guy is playing with a consecutive structure, and our sixth session was about consecutive structures, and this is an example of what we have implemented in Grasshopper environment. That is a consecutive dome, and so it is a kind of related to our next topic, which is membrane and tensile structures. Tensile structures is one of the unique complex structures. Its structural members can only carry tension, but there can be no compression or bend. It normally consists of exterior fabric material with its framework, such as cables. So they are very efficient in structural performance. The fabric and the cables are maintained in tension in all directions. So to provide stability, membranes are one of the common fabric materials used in nature, and we see it in our day-to-day lives. A membrane, as this image is one of Gaudi's experiments for his catenary forms. And membrane is a tension between rigid structural elements such as steel frames or flexible structural elements cables. The membrane itself can resist external loading only through increasing tension in the membrane, which results compression and bending in supporting elements. So they are so efficient in terms of structural performances, and we have some simulations with a Kangaroo component. It is developed by Daniel Piker. We use a dynamic relaxation method for load simulation, and actually some of the students use it as their main tool in their toolbox. My second workshop was artificial intelligence in architecture, exploring GAN. It was a more advanced level workshop. It was about artificial intelligence, as the name suggests. We went through basic concepts like what is AI and what is the difference between various forms of AI, like ML, machine learning, and deep learning, of course. And we continue to explore more advanced topics like generative adversarial networks. The workshop stated with basics of artificial intelligence to advanced topics like generative adversarial networks, and the discussions and teachings were most about the summary of artificial intelligence, machine learning, and deep learning, a brief mathematical explanation of neural networks building blocks like layers and neurons, getting started with neural networks in TensorFlow and Cross, and the basics of machine learning and how they work, because it is like a black box. We know how they work, we do not know how exactly they are working under the hood. We have some introduction to convolutional neural networks, the most favorite, the most famous forms of deep learning in computer vision field, which was first invented by Yann LeCun, a French computer scientist, who is now the head of Facebook artificial intelligence team department. And after that, we trained some convolutional neural networks on a small data set. After that, the next session was about using a pre-trained convolutional neural network and some implementation in Cross framework. The more advanced topics include neural style transfer and the introduction to the cycle GAN and implementing cycle GAN and tips on how to improve the performance of our networks. Three different realms of the AI and the relationship between them were discussed, and we have discussed some ethical issues of AI, like the bias, how biased the data we use, and some discussions like that. I believe this is important. It is very important because our goal is to be more equal. If our data is biased, so we are not going towards equality. And the first part of the workshop was about some history of artificial intelligence or computers, like in Victorian England. Lady Ada Lovelace was a friend and collaborator of Charles Babbage, the inventor of a machine that they call it analytical engine, the first known general purpose mathematical computer. It wasn't meant as a general purpose computer when it was designed in 1830s, I guess, because the concept of a general purpose computer was yet to be invented, as Alan Turing was quoting. Ada Lovelace was pondering whether general purpose computers could be capable of learning and originality. He came to the conclusion that they could. Machine learning arises from this question. Could a computer go beyond what we know how to order it to perform and learn on its own how to perform a specified task? Could a computer surprise us? Rather than programmers crafting data processing rules by hand, could a computer automatically learn these rules by looking at data? After such a brief history of AI and Alan Turing, Ada Lovelace, these people, we explore, we define the basics of what is machine learning task. The question, the before mentioned question, opens the door to a new programming paradigm in classical programming, the paradigm of symbolic AI. Humans input rules program and data into the process according to these rules, and the outcome answers uh, and the outcome answers. Uh, Excuse me for a second. I think I should check my connection. Okay. And the difference between the classical performing programming that it was hard-coded and the machine learning systems that it is trained rather than explicitly programmed. The participants get familiar with these ideas and concepts. And I have mentioned Yann LeCun before. He is the godfather of deep learning, of course, with Jeffrey Hinton and Joshua Bengio. They have made a lot of contributions to the field, and he was first successfully explored and introduced this idea of deep learning and convolutional neural networks in 1989 when he was working in Bell Labs. But the field of AI went through some winter that Francois Chollet called it the second winter of AI. But after that, some person in 2011 who is called Alex Krzyzewski had make a breakthrough to the field, and it is just some history of the field. So I'm going to the next part. The next part was to know what makes deep learning special, and why now, why this time of the history it is going to make it, because it offered better performance on many problems and makes problem solving much faster and much easier, because it completely automates what used to be the most crucial step in a machine learning workflow, that is called feature engineering. And the thing that why now it is so successful, because of the scarcity and the abundance data we had because of the internet and the good hardware, like very powerful GPUs, and the implementation of better algorithms like Armstrong and other algorithms. After that, we had some discussions about data representations in this field, that the tensor, it is a container for data, almost always numerical data, and in the context of tensors, three key attributes we have. The first one is number of access or rank, or the second one was the shape, and the third one is the data type. We had a lot of discussions with our students, of course, because it was a very long workshop. We had more than 30 hours in 7 days. So I skipped some of the parts, and after this topic, we explore basics of machine learning. Machine learning is like uncrumpling a paper ball. That is finding the neat representations for complex, highly folded data manifolds. At this point, we should have our students have a very pretty intuition As why deep learning excels at this, that it takes the approach of incrementally decomposing a complicated geometric transformation into a long chain of elementary bonds, which is pretty much the strategy a human would follow to uncrumple a paper ball. After that, we have some intuitions of how it works in a nutshell, and we conclude our discussions that we had before, and something like 3 stages of AI, that we are now in a stage 1, that it is narrow AI, that AI is doing some dedicated tasks, and it is excellent in those tasks. But we don't know when we reach general AI or maybe super AI. We don't know about that. After that, we had some examples of some famous convolutional neural networks. The first one was LUMAT-5, which is invented by Jan LeCun. The second one was AlexNet, that Alex Krzyzewski, who was a PhD candidate, and his supervisor was Jeffrey Hinton, who made this network, and it was a breakthrough for the field of AI. After that, we explored ZFNet and VGG16 and excuse me, and VGG16 and the architecture of these models, and we explore some concepts like networks in networks, that is called 1x1 convolutions. That is a very important concept in this field, and inception or Googling, and residual blocks that resonate on Microsoft. We explore this architecture because we were about to use it in our GANs implementation, in cycle GANs implementation, use some kind of resonance. And the idea, and the last and the most important part of the workshop was neural style transfer, which was an introduction to this part of cycle GAN. Cycle GAN was the most important thing, and neural style transfer was like an introduction to cycle GAN, excuse me. At this part of the workshop, we explored more advanced topics like neural style transfer and, of course, the well-known and notorious generative adversarial networks, specifically cycle GANs. We have trained a model on some Van Gogh paintings. It is just one of the examples we had done in this workshop. We had trained a model on some of Van Gogh's paintings, and as the style image, and feed some architectural images like buildings from San Francisco to the network. And after 400 epochs of training, the result was like something like this. It was an implementation of neural style transfer on architectural images, and this one of the problems we have in Iran, that we have a very limited access to some cloud computational services like Google Cloud or AWS, Amazon Web Services, and actually we cannot have some cloud computing services like these services. We should run these networks on our machines, on our local machines. So it was very time consuming and very expensive for us. Like when we want to train a cycle GAN network, it takes us about 2 or 3 days. The result on the cycle GAN is this picture. It is a very famous benchmark. The authors of the cycle GAN did mention this benchmark in their published paper. So my students get familiar with cycle GAN, and after the workshop, it was one of the interesting and surprising things that happened during the workshops, that some of my students approached me and suggest that we should try to collect and gather some architectural data sets and make it free and open source for the field. But we know that collecting and gathering data sets is very time-consuming and expensive. But the idea of an open source architectural data set came to our mind during the workshop, and it was very pleasant to see the passion of these students in Iran. So thank you. That was it. I enjoyed being here. Thank you very much.
Thank you. Thank you so much, Muhammad, for this insightful presentation. And it's great to see the breadth of processes that you and your students explore together. I would like to congratulate you on the success of both of your workshops. I would like to say that I'm personally pleased to have had all of the instructors with us today. Thank you so much for shedding light on the talent in Africa and the Middle East region. And I think it was also great for us to see the number of participants that were engaging with us from these regions as well. And I feel like that truly reflected our inclusive umbrella at Digital Futures. So thank you everyone again.
Thanks, Aya. And thanks everyone. I believe Digital Futures is the beginning of something big, especially Inclusive Futures 2021 intended to establish bridges across different civilizations. There is something that can transform not only education, but the world and its view on humanity. It's time for unity, for my guide to brought together. It's a demand for brighter future for everybody, for you to begin studying and gain knowledge needed. Thanks everyone. See you next Saturday. See you next. Professor Neil, do you have something to say before we close?
I thank you for, everyone today. It was a really great presentation. It's good to see such talent. First of all, I have one request. Can we not use the word Middle East? Can we say West Africa, West Asia rather? Sorry, because Middle East implies east from where? There is no center. Maybe we could think of that. But I just wanted to this was really a great session. I saw such talent on display, and I saw such promise. I mean, I just want to echo your comment. I mean, this is the beginning of something. I don't know what it's the beginning of, but it's really encouraging to see. I want to hear you finally finish up, each one of you, in your own language, say a few words, because I think it's one of the points I was very proud about this Inclusive Futures was the fact that we had 10 different languages, and in your region we had Farsi. We have Arabic, and we had another version of Arabic called Egyptian Arabic. But to my mind, this was great to see, and it just finally want to sort of find a comment. One thing I've mentioned this from teaching in a place like Dessau, which is a school that's so cheap and gets people from all over the world who can't afford to study elsewhere. Talent is universal. Talent is absolutely universal. No, it's not. You find it everywhere around the world, and it's great to be able to sort of give a platform for people to be able to show what they can do. And today I saw such incredible talent in from your region, and it's really encouraging. It's really encouraging to see that. And I don't know. I've just been thinking, how can we take this further in terms of the next step? Because there is a next step, and I'm not quite sure what it is. But I was really blown away by the standard of the presentations today. So I don't know. it'd be nice just to have a very brief conversation before, rather than wrapping up, because I think we got some very talented people here, and maybe we can even have a discussion about that. What could be the next step in terms of how we could take this further forward? I mean, I was learning from Mohammed. It was a great presentation, Mohammed. It was a bit longer than expected, but it was actually incredibly informative. And I'm just thinking, how do we bring this knowledge together in a more coherent way that makes it into something that is structured in some way? But maybe we could have a brief kind of discussion about those things, about what could be the next step in terms of these things. Is that a provocation in its own way? I mean, one thing I'd say, Summer has had an incredible experience around the world in collaborating and being part of all these different institutions worldwide. At the same time, coming from a part of the world that is still in many ways underprivileged. And I'm just wondering how collectively you can think how we could really take this further forward.
Well, if you'd like to hear my insights about that, I think in two parallel paths. First one is establishing something like an academy, maybe in something like what we call the parallel education. And the second one is collaborating with with foreign institutes, universities, maybe schools of architecture all over the world, making well, we have an experience with the AA summer school. So, but what I have in mind is something that is much more bigger. It's something that would be the seed for a new research center that we will be establishing today, collaboration with the formal bodies of education, collaboration with the research centers, and having our own research. That would be a very important step. The second one is creating something like an academy that will be conducting its own research and then educating this research and having postdoctorate students maybe publishing papers on its own. So I think we have to consider that. I think this distinguished group will have a lot of network of relationships. So I might share my network of relationship with you if you have something like that in mind. We can cover all of the what I'm calling the marketing. It's not appropriate word, but it might give you what I have in mind. We can really publicize our activities with the public and share it with the academics, with the scientists. I think that would be a very good, important step. Thank you.
Yes, so yeah, I agree. Actually, I don't know if you're aware, but we did have an initiative this summer which we set up called the Digital Consortium, which was trying to establish a platform that was kind of universal in terms of, particularly for doctoral students. Doctoral students around the world could come together and share this. I mean, the premise behind it doesn't make any sense anymore to have one professor in one school, one classroom teaching one group of students when we can have this universal kind of collaborative thing. And I think especially for doctoral students that typically are on their own, and most institutions don't have the facility, or apart from maybe MIT, to really cover the kind of the instruction and so on. I certainly think that the idea of pooling resources in some way makes a lot of sense. And sharing knowledge, and trying to find a way to structure it more coherently. But that was a useful contribution. Maybe Omar has studied at IAC. I don't know if you're one of my students. I used to teach there, Omar. But it's I'd be interested to know what you think, having studied in a Western, a leading Western school, IAC, and how you think one could maybe take things further forward. IAC in many ways was kind of interesting as just say for those who don't know, it's in Barcelona. It's a very experimental school, and it was kind of set up as a, let's say, the way I see it anyway, to address the gap, as it were, in education, that no one was really teaching some of these advanced computational techniques, and it was there to do that. And I had assumed that somehow it would cancel itself out. Everyone would be teaching this, but actually it's still there, and it still has an important role to play. And I think I was really gratified to see, Omar, you taking the skills that you'd learned in a place like IAC and bringing them back to Egypt.
Yeah, so I think what we're missing here in the region mainly is opportunity. It's not like the skills or anything. Is just the opportunity. So this opportunity, I'm kind of privileged that I was able to travel abroad and go to the master. I'm also kind of privileged that I understand English and I can speak English. So this opens up many possibilities for me, but many here don't have this kind of opportunity. So we would like to democratize this education and bring the opportunity and the knowledge to where these people can access it, our people in the region. So this is something that I'm trying to do, and I've already did online courses in Arabic. I'm planning on doing more and more courses in Arabic so that I can transfer this knowledge that I had abroad into our country. Also, this is something that Ahmed is working similarly on with a lot of free workshops. So I've seen this in the workshops. So many people didn't bringing this technology here in Egypt. Many people, when they had the chance, people from Egypt, they really excelled in the workshop, and I was surprised by the knowledge, the output that they did, and people who actually didn't know Grasshopper before and just learned Grasshopper for the workshop and then did all of that. So it's just opportunity, democratizing the opportunity for everyone here in the region.
Maybe I could ask Zayed, because I think you're from Iraq, right? And of course, we have in fact, I'm from England, and we have a very special relationship with Iraq through Zaha, and we know what talent comes from there. And of course, Shamin Youssef is also from there. And you're now teaching in China, so you're really kind of total global citizen. What's your perspective on things?
Yes, thank you, Neil. Yeah, I used to run as well this UNAT network in which I established in Dubai exactly for that reason in 2014. And at that time when digital design wasn't well known, in that region, despite there are so many architecture schools, I found there is this eagerness through a lot of students there to attend these courses. So suddenly DNAT started as a small network teaching kind of some workshop based on certain digital processes into a bigger hub that really attract a lot of people in the region, which I realized there is a lot of eagerness there, and there is the schools there. Unfortunately, they still not up to speed into kind of coping, with this level of knowledge. So yes, I was between Sydney, now I'm in London in China, so I'm as well kind of move a lot. I think I could think of two things, now. The idea you mentioned about PhD students, I think is an excellent one. If we say that based on certain thematic concepts, so we say there's going to be a talk about, for example, machine learning, a panel about machine learning, then every one of them has taken a different path, as you know, in PhDs about machine learning. And then that's become a bigger hub about the different paths that we create awareness, global awareness among them all about what each one is doing. And I think that is a good progressive, things to happen, bringing kind of different people working on a similar field individually in different parts of the world into one hub. And the other concept in the idea that I think Omar mentioned about accessibility of this knowledge to people in the Middle East. Most of them, I even ran a few workshops in Baghdad when I was allowed to go. And when I realized language is really a big barrier to a lot of them, because if you teach it in Arabic, that will open the door, because a lot of them, because of their language, they're shy to come forward and to express themselves or their concepts, so they rather not apply. So I think if we open that shell and we say, well, it is the multilingual workshop, it's English and Arabic, that will make a lot of people, come forward. And I think if we kind of do them this way, then we say, well, these are really for more preference for Arabic speaking or people, or Persian speaking people, or in a kind of different thing. So I think it could maybe have bigger outreach, into those people who don't want to come forward because they feel a bit intimidated, by knowledge and by language. So these are the two things I could think about.
Yeah. Maybe Heba, you're actually in the Barber in London right now. What's your perspective on what we could do to kind of make this happen?
I also came. Sorry, can you hear me now?
You've got the echo still. Do you have another device there that you're getting feedback from?
Yeah, sorry, because
Yes, I think now it's fine.
Okay, good. Yeah.
Yes. Actually, I studied in University of Sharjah in Dubai, and that was another problem because, as Zayad mentioned earlier, in that region, in the study, in the education, there's actually no direction whatsoever towards computational design. I mean, there are some universities, some courses, but in general, there's no really any input for computational design at all. So yes, in order to, I think many people, for them, it's still very much intimidated by the whole idea, and to actually have it in the university will make a huge difference. Because I know, for example, now many of my colleagues in the University of Sharjah, they had big problem in even opening Grasshopper. They're so intimidated. They think this is, you know, from outer space and they cannot really deal with it. But then the minute when they break that barrier, everything becomes easier. But yeah, I think the main problem is the education, the staff, even the staff that's coming from different countries to teach in University of Georgia, for example, they're still very traditional in terms of architecture. They prefer the very modernistic approach towards architecture, and anything other than that, they kind of don't really agree on it in a way or another.
So it's about breaking down barriers, both language barriers and also kind of perceived barriers, shall we say, in terms of knowledge. Maybe Mohammed, you could from Tehran. What would you? I mean, I've got to say that I spend my life surrounded by some very talented Iranian scholars from all over the place, having worked with Baruch Khoshnevis and having taught under Moisa Mustafavi and had an office next door to Farshid Musawi. So I'm very much aware of the talent coming out of Iran. What would you like to sort of comment on how you think what is the next step forward? I mean, Iran is, of course, in a very difficult situation financially in terms of, you know, nobody can afford to study anywhere at the moment abroad. Ahmed.
Yeah, it is that difficult, and we have some difficulties, some economical difficulties nowadays in Iran. But I think I should agree with Omar, who mentioned the democratization of education. We should democratization of education. Yeah. We should democratize the education because I know the situation here. I'm living in here, and I see so many talented people that who are not so privileged to go abroad and go study in some top universities. Of course, they are very talented people, but they cannot afford living abroad. We can just democratize the education for those people. And another problem I think that Heba mentioned, we have some problems like that in Iran too. Most professors and most teachers, university teachers here, they are more traditionalists. They are not into computational design. They just want to see some traditional architecture. For example, if I do some computational design, they want some inspiring things, some inspirations from our traditional architecture. For example, I should be inspired by Isfahan architecture, but in some cases, it is not relevant to be inspired by traditional architecture. In some cases, it is relevant, it is logical, but in some cases, it is not rational. but they want to see this, and I think it is a rooted problem. Yeah.
Thank you, Mohammed. Yeah, no, um, yeah, this has actually been a very useful little discussion. So I was thinking about all these things as you were presenting because I was just so blown away by the presentations today. And, it really is, having just achieved this, the step forward in terms of inclusive futures. And I think it's a really important one, inclusive, to be actually, the thing I'm most proud about is the fact that we have 10 different languages that we were teaching in. And in your region, of course, these Farsi in Arabic. And I think that's really, really important. Maybe it could be in others, Syrian and so on. But it's, I think it's kind of having achieved that, you kind of you think, well, okay, what have we done? Then you spend a while trying to think, what have we done and how do we move forward? And when you're very forward looking the whole time, you don't tend to look back, but it's now is the time in the weeks after this Inclusive Futures event to really think through the possibility of what went right and what went wrong and how we can take it further forward. I think my hunch is that really it's about kind of facilitating things rather than replicating what's there already. I don't know necessarily if we could establish an institution as such, but certainly the possibility of allowing that sort of dialogue. It seems to me that the kind of question of language is an important one, and how do we manage to get these ideas across in different languages? And it's difficult on this platform. We have to use one common language. I always tease Ahmed and said, yeah, we use English, but we use your numbers, right? It's Arabic numbers and things. But how do we manage to kind of distribute that information? And I'm just thinking that maybe someone like TED does that very well, right? They have transcripts in many different languages for their lectures. Now, how could we possibly manage to get transcripts in different languages for different people for all our sessions? And whether we could use AI for that is another kind of question. And I guess I think I'm left with the kind of the thought that Philippe Morel came up with last about a few months ago, and he said basically, I think the role potentially Digital Futures is a bit like the role of Uber in the terms of Uber versus taxis. Uber forced taxis to improve their logic, and I still think that maybe that's the way that we can go forward, is by presenting some sort of auxiliary form of education that will kind of help to push forward mainstream education, because I completely agree with the comments that Mohammed's coming out. And not that I'm against, I mean, I think, of course, you have wonderful, Isfahan is fantastic and so on, but, it's really a kind of question of not, the students are eager to find out, and sometimes you're faced with this kind of barrier of these professors who are kind of, who are locked into an old-fashioned world. I would want to give, there are many of stories I could tell about that. But the question is, how do we make this happen? And I think maybe this dialogue is the first step towards that, to try and really think through and brainstorm how we can go forward. Maybe I could just draw upon our team in some ways also while we're here, and maybe Aya and Gustavo and Nico, who are also here, to kind of comment on where we could be going from the next step, just briefly.
Thank you, Neil. I think like a thought that just came to mind during this discussion is, and I think Heba and Muhammad also kind of shed light upon it, is the kind of the leading, let's say, authority figures in these main institutions around the region that are very reluctant to kind of progress and kind of figure out new ways of design and computational design and introduce new tools and ideas to their students. I personally see that as the main hindering factor in the region, because when you have your major institutions run by individuals that are very reluctant for this progress, then all of the generations that are coming into this institution are affected by it. And as time goes on, these students kind of are, once they go out to the real world and they kind of find themselves a little bit behind in terms of these computational tools or these ideas, we're not really doing them much justice. So I personally believe that the change kind of needs to happen from the top, and I'm not sure how. I personally am kind of trying to do these things, and it's a struggle, but yeah, I see progress happening from the top of these and changing the kind of mentality of these institutions.
Maybe I mean Gustavo's someone who's I think got more degrees than most of us have books.
No, I wanted to say thank you everyone for presenting today. I mean, it's very inspirational to know that there are others that feel the same way and that want to change the world for the better. I mean, I guess I'm here in this group to make positive change, and I see a lot of inequality and opportunities lost. And my professors taught me that the world was kind of infinite and large, so that we would have resources and economies and philosophies would help people. But that's not true. That's a lie. So as architects, what are we willing to do? And some of us are tenured professors. Some of us have 2 or 3 incomes. Some of us have family and friends that are in need. So my belief is if we unite somehow and have a dialogue. So we are the power. If you think about it, we do the work. So why aren't we setting policy? And I'm fortunate to write about the future of California and my current project. And I'm looking at the state, but the country in a global perspective, and how digital futures also impacts that. So how do we come together? So I would say this to all of you. I mean, thank you for volunteering your time, but also think about this. If we do the work and we have the visions and we teach the students, then we need to have more, we need to have a voice at the table. And for power to continually say no, that means that we're giving them that authority over us. Anyway, and a lot of this belief also came from a year speaking with Neil. I mean, this is a very dynamic project, but you know, we have a lot of energy to give. So thank you.
Thank you. I don't know, Nick, I don't want to put you on the spot, but you're in a unique situation in that you're from one of the most ancient civilizations. I mean, China goes back 3,000 years, and now you're a lecturer or assistant professor, as it were, in Australia, one of the most dynamic young institutions and one of the most dynamic young. Well, I wouldn't. I mean, there's also the Aboriginal culture, of course, but it's. Sorry, I'm stepping in different territory here. But Nick, what is your and also what I think was Australia is really unique in many ways in that now we've realized that it's really it's not part of the British Empire, it's part of Asia. And what's your perspective as someone from China working in Australia? Oh, maybe Nick's not there. Okay. All right. Well, there's a lot to digest today. I wanted to just maybe we could wrap it up now, but I think we want to take these thoughts further. So maybe over the next few weeks we can also start thinking with other groups to know what might be the most appropriate next step in terms of kind of making this happen. Because I think a lot of us share and what Ahmed articulated very clearly, you know, about the possibility that we need to do something. We need to, and I think democratization of education is precisely that sort of that role. And quite how we do it most effectively remains an open question. But thank you for the contributions today, and let's see how we can take it forward.
Excuse me, can I just add one small addition? I have something in mind that I want to share all with you. Well, in the age of social media and the crowdsourcing, I think it would be a very good catalyst to launch something like challenges, competitions, which is defined as a crowdsourcing much more than a competition. Crowdsourcing is some kind of a hybrid, some architecture competition, utilizing the same model of the social media in solving problems related to our discussion and dialogue and the democratization that you would like to launch, you know, this kind of parallel education. So I think that it will be an incentive and a catalyst that will accelerate the process. And it might be the middle link between, you know, enterprises and students, or even engineers or architects that would like to share in this crowdsourcing. So just to make it brief, that is one thought that I would want to share with you.
Samer, are you volunteering? I would just say what Samer and I share is experience of working in space. I mean, Sana's got way more experience than I have, but I do think that one thing that realm opens up is it inspires people. It forces people to imagine other futures, and I think it's a particularly kind of, and right now, of course, it's a really hot topic because everything's happening in terms of the space industry and so on. But I think all these are kind of these are helpful. I think the key thing is resources in terms of kind of trying to cover that area. If we could certainly, I mean, I'm sure that we could set those things up. It's really a question of more people being able to volunteer their time to make these things happen. But we had Valentina was also offering a workshop in space architecture. Yeah.
And we have agreed to share a workshop next time.
Oh, really?
So, okay. Yeah, we both will be instructing that. Yeah, I know Valentina.
Yeah. Ahmed, let me leave the final word for you because you've been a source of inspiration for us all along.
Thank you, sir. I agree with everyone that we need to democratize education, but the point Omar mentioned about bringing opportunity for everyone, or let's say democratizing the opportunity itself is so important. This is why we discussed and we're still discussing the idea of how we can issue a certificate somehow to help people not privileged to continue their education or something like this to move forward into their lives. We're still looking for possibilities and opportunities, and looking for ideas how we can help and push the limits so the students can be prepared for the futures, their possible futures. So if you have any ideas or thoughts and would like to share with us, we are open to discuss these ideas. You can write down your ideas on YouTube or send it on Discord, and we will discuss the ideas how to take this forward, and how to democratize education and the opportunities as well. Next week, we have a session by Gustavo hosting East Coast North American workshops. See you next week, and thanks for everyone. Good luck. Bye.
Thank you, everyone. Thank you.
Thank you, everyone.
Thank you, Ahmed. Thank you, team. Thank you.
Thank you, everyone.
Thank you.
Thank you, everyone.